In this video, we are going to solve for you an example from chapter 2. Remember, chapter 2 is talking about limits and their value. The question that we are posting here, evaluate the limit as x goes to infinity for the square root 4x squared minus 2x plus 1 minus 2x. If you wanted to evaluate such limits, so how are we going to think about this problem? Well, first of all, we're having here the square root, so we might think about the radical conjugate. But how we are going to introduce the radical conjugate here? Well, the key thing is that by multiplying by 1. But now you choose your 1 to be in a special form that's having the radical conjugate. So we are going to multiply by the radical conjugate as follows. Okay, remember that in the numerator, now you have two factors. These factors, their product is going to be the difference between two squared. So when you are multiplying these two factors, we are going to get the difference between two squared. The square of the first term and the square of the second term. Therefore, when we're applying the multiplications, we are going to get limit as x goes to infinity in the numerator 4x squared minus 2x plus 1 minus 4x squared. Divided by the denominator square root 4x squared minus 2x plus 1 plus 2x. Now, we could simplify the numerator a little bit. You could notice that we could cancel 4x squared and minus 4x squared. Therefore, we are going to get limit as x goes to infinity minus 2x plus 1 divided by square root 4x squared minus 2x plus 1 plus 2x. Now, if you wanted to evaluate your limits, so when you are seeing these expressions, how are you going to proceed from here? Did you make it more complicated when you multiply by the radical conjugate? Well, actually no. Remember, this could relate to you some limits that we have a result for, which is the limit when as x goes to infinity 1 over x to the power t, this limit equal to 0 if your t is a positive number. Well, you could think about taking a common factor from the numerator and the denominator. So in the numerator, you are going to take x as a common factor. So it is going to be multiplied by minus 2 plus 1 over x. And in the denominator, inside the square root, you have x squared. But be careful. Now, if you wanted to take this x squared outside the square root, then it's going to be equivalent to the absolute value of x. Now, the absolute value of x have the definitions of it is going to be either x if x is positive or minus x if x is negative. Now, we didn't take the value 0 because we are talking about a number in the denominator, and if you take it as a 0, then the denominator is going to be equivalent to 0, which is going to make your expression undefined as a real number. Okay, now since your x in the limit goes to infinity, so we're talking about positive values. Therefore, when we are taking the absolute value of x, we are going to take it's equal to x, not minus x. Hence, we could take now the x as a common factor from your denominator. Remember that also we have an extra term in the denominator, 2x. So if you're taking the x, you are going to take the x as a common factor from the whole denominator, not only the square root. Okay, now from here, now if you're having a common factor in the numerator and the denominator, which is x, then you could cancel them out. And now your expression is going to be the limit as x goes to infinity for minus 2 plus 1 over x divided by the square root 4 minus 2 over x plus 1 over x squared plus 2. Now, since both of the limits in the numerator and the denominator exist as x goes to infinity, so we could split the limits over the quotient as follows. Remember, that is the limit as x goes to infinity for 1 over x to the power t is equal to 0 if your t is a positive number. So, therefore, 1 over x, 2 over x, 1 over x squared, all of these, the limits as x goes to infinity, they will go to 0. Hence, the value of your limits now is going to be as follows. In the numerator, minus 2 plus 0 divided by square root 4 minus 0 plus 0 plus 2. which is equivalent to the given value of your limit, which is eventually you are going to get minus 1 over 2. And this is going to be the value of your limit. I hope you enjoyed your video and you find it useful for you. See you in other more videos and other examples from different chapters.